All today I'm going to be starting a new series called I Can Code That. I got this idea from kind of just like walking through life and seeing a bunch of things over and over again when I'm looking at it, and I'm like, I could just code that. And so I thought I would, just actually do the thing. And the first one I'll be starting with today is something called Snakes and Ladders. This is actually a board game that I was playing a few days ago, and when I was thinking about it, it seemed like a really simple idea. So if you aren't familiar, this is kind of like what one board looks like. There are different iterations of it. The one I actually have is not this one, but this is a nice visual. So the idea is you'll have like 2 to 4 players at one time, and you roll a die, so 1 to 6, and you move that many spaces. The board consists of tiles between 1 and 100, and the goal is to get to the 100 tile, basically. But along the way, if you land on a ladder, you get shot up to a new location, and if you land on a snake head, you get sent back down to where the tail ends. You basically like fall behind when you land on a snake. The players themselves don't interact with each other. It's just you traversing the board on your own, essentially, and the only real interaction is when a player gets to the end and the game ends, basically. So let's do this thing. So I think I'm going to start out by I'll be tackling this with like a kind of object-oriented approach. So I want to first define a game class. So that's what I'll do here. And I'm going to call this game, the class is going to be Snakes and Ladders. And so the first thing I want to do is establish basically a dictionary of the snakes and the ladders. So this is just going to be like object with key value pairings. Okay, so here are our snakes, and the keys basically will start out in one place, but then it sends you down, so that's why the number is smaller always for the value. Same thing with the ladders. It's just the opposite. When you land on a ladder, you get sent up to 1. Again, these numbers are not from this visual. This is a different board than the one I was playing on. So what I'm showing you here is the board I was actually playing on. What I also want to establish is what the last tile is. This is tile 100. So just in case you want to expand on this, you can make 1,000 tile grid if you wanted, so you can really do whatever you want with this once you have the code. So I think the way I want to start out is when this game object is instantiated, we have to define the init function to have some things set up. So I'm going to say n players, and I'm also going to check to see if this is verbose, because I will want to print some things out depending on if I want to like actually see what's going on in the game itself, versus if I just run it, I just want to basically know who the winner is. So that's kind of the idea why I want verbose or not. And verbose is spelled with an O. Haha. Okay, so I'm going to start out by saying self n players equals n players, and self dot verbose equals verbose. The other thing I want to instantiate is a representation of the players. So I'm going to represent the players as just a list of positions that each player is on, and the index within this list is the player, basically. So I'm going to start out with 0 position, and I'm going to multiply that by the number of n players. And just so you know what that looks like is if I start a list with 0 and I multiply by like 10, that means 10 players, each representing what position each player is currently at, and they're all going to start at the 0 position for now. I also want to keep track of which turn it is. This is for the verbose setting, so I can kind of tell like, oh, turn 1, 2, 3, what's happening at that point. So I'll say turn, I'll start out at 0. I'll also keep track of a winner, so self.winner equals none. This is something I can use to determine if game is over. I'll also use this to define who the winner is, so that at the end I just return the winner. Next thing I want to do is basically have a roll of the die. So I'm going to define die roll, and this should return a random number between 1 and 0. So I think I need to import rand. Oh, sorry, I should say from random import rand int. And if I do that, I say rand int and 1 through 6, I believe. If I run that a few times, it will ever give me a 1. Yeah, okay, it gives me a 1. Gives me a 6 for sure. It gives me a 1 as well. So I'll just return that. I also want to import this. I'm going to move this up 1. So now it's at the top before my class. The next thing I'll want to define is how do I move a single player. So I'm going to define move player, and I'm going to provide this with the player index, player I. and I'll be able to pick out what position that player is on currently. So I'm going to say previous position equals self.players, which is my list representing the current position each player is in. And I'm going to say player I, and their new position is going to be their old position, previous position, plus the self die roll. So plus 1 through 6. Now here's the logic. So basically, I want to check to see if this person is 1. So I'll say if the new position is greater or equal to self dot last tile, which if you can recall, we established as 100. That's our last tile, and that's going to be, we have a winner basically. Winner, game over. And I want to say self dot winner. So this is where I set the winner to player I. I also want to set the new position to whatever the last tile is, so that technically in the players list here, they'll be at the last tile instead of like a little bit over. I just want to be really particular about that. Otherwise, so elif, we need to check to see, hey, are you in the snakes dictionary? That's basically checking to see if that new position is one of these keys, because if you land on 29, what you need to do is actually go back to 3. So we need to actually set that up here and say, if you are a key in this dictionary, then we set our new position actually to the snakes dictionary with the lookup to the new position, which will give us the kind of redirected position basically. And we just do the same thing for the ladder. So self snakes ladders, and now these 3 will establish what the real new position is. If none of these are true, then the new position is just some blank position that doesn't do anything special. Okay, so what we want to do is basically set where that player is. So we need to go into the list and use the player index and set that to whatever the new position is. And that's how we move a player. So let's actually run this, because we can now start testing some stuff. We have some methods established. So I'm going to call the snakes and ladder. I'm going to instantiate our game equals snakes and ladder. We need to set the end players to 2 for now. I'll run that. End player, I meant end players, sorry. And game.players is the list of players. We have 2 of them. Actually, let's make this like 4, just so, or 5, whatever, 4. So we have 4 players now. And if I say, okay, game, I want you to move player 0, that's the first player. And if then now they should be moved, and let's see it, players, we can see they were moved to number 16, which is weird because you're rolling a die between 1 and 6. So that must mean that they must have landed on a really good spot for a ladder. And we see here a 4 corresponds to 16. So it looks like this person landed on a 4 and actually got a ladder. Okay, cool. So that looks like it's working. Okay, now let's make a new method here called move players, plural. What I want to do is basically iterate through each player and then have them move. This is effectively like what one turn looks like, one round for all the players. So let's define move players, plural, self. We don't need a player index because we're going to be the one establishing the index, and we'll be calling this method the move player method. So for player I in range, self dot n players, so for each index there, we can call the move player command, so self dot move player, and put the player index in there. That will move the player, but the thing is, I don't want to like have multiple players potentially win. So I need to make sure that I check after we move a player, is there a winner at this point? And so I can check that to say, hey, if self.winner is not none, and if you recall, self.winner is established up here as none. If it's not that, then I want to break this loop. I don't want to have any more players roll because the game is over. So this is like we're done with the game. Okay, so let's run that. Let's go through this. Players look like that. I don't want to move player anymore. I want to just move players. So each player has now taken a move, and let's see that and look at that. We have 2 25s. I think 25, if we look at the ladders, corresponds to getting a 6 on the first roll. Okay, cool. So that looks like it's working. So now that we have a function that iterates over each player, Now we just need to have another function that just like plays the whole game, which is actually iterating turn after turn, letting the players keep playing until someone wins. And I'm going to call that play game. Okay, so I'm going to basically make a while loop. So while the self.winner is none, so while there is no winner, we just keep looping. And we can increment self.turn. I'm going to add 1 to the turn. And self.move players is in effect. So we'll have them move all the players. And this is where I might do the verbose check. So if it's verbose, I want to actually print, hey, here's the turn and here's what happened with the players. So I want to say if self.verbose, just a Boolean true or false, I'll have a helper method called self.print progress or print turn or something like that. And then at the end, I want to return the winner, self.winner. So that when I play the game, I just have like a winner return. Okay, so let's self. Oh, I said is, so it should be if. So if self.verbose, verbose is set to false initially. So if I run this game right now, it's going to start with 0, 0 for everyone. We're not going to call move plays. We're going to say play game, and it returned 2, meaning that the person in the third position, the index, is actually at 100. Okay, so the third person won. So yeah, we played the game. We're done. We're kind of done. I think I want to clean this up though. I need to create this function called print turn. Also, I don't like this format for the winner, so I think I'll have like a f string here that shows like the player number whatever. I need +1 because I don't want the 0 index wins. Now if I run that, player 4 wins this time. Okay, cool. And it's, not 0 is 1 index, so it's more typical how we think about playing games. Okay, so now I just need this print turn function, and that's kind of it. Define print turn, and I have everything internalized in the object. The turn, the players, all that stuff is in there. So first, let's print the turn. Print, do a lot of f strings here. Turn is self.turn. I'll also do, I think it's just self.turn because I think it's already 1 in, yeah, I'm starting at 0, I think. Starts at 0, and then before anything happens, I +1 on it. So it's currently at like +1. So it's already 1 index basically. So that's good. So you print the turn, and then I want to print players with position. Okay, so I'm gonna have my player string, player position string is equal to, it's a list, so I want to do a join, and I think I can iterate. So I'm going to do a list comprehension here of for player position and player I in enumerate and self.players. So that's the list of players, and I have the position and the player index, and I have my string here, which is going to be I'll do f string and say player number player I at position. Okay, and then I just print that, print player position string, and I think that is it for that. So let's run that. Play game. Oh, it's not on verbose. So yeah, so this only gets called if verbose is true. So I need to instantiate our game with verbose equals true. Okay, there we go. All right, so this looks like a hot mess. I don't like this. Okay, so player 2 at 0. There's no, okay, the join is a little weird. So let's put like a little bar between them. So it looks, okay, it looks a little bit better. I don't love the player because it's like really repetitive. So I think I might just get rid of that, to be honest. Let's like get rid of that. Just put like maybe parentheses around it. I don't need the at really because it'll be super obvious what's going on. Okay, cool. So player 5 is at 0, 16. No, sorry, no, this is, wait, hold on, that's the position. Wait, what? Player I. Oh, did I mess up enumerate? I think I did. I think I got these swapped. I think this should be player I is here and position is there. So enumerate actually puts the index first. So let's redo that. Okay, it looks a little bit more sensible. This should be player +1 though, because I think I want to keep it in the index 1 position. So player 1 is at tile 1, player 2 is at tile 16. So this is a little bit more readable. Plus, if we have more players, like 10 players, it can, I think, all fit on like kind of one line, so it makes sense. What I don't like though is that it's in like non-order. It's in the standard 1 through 10 order, but I want it to actually sort it. I want to see the players in the right way, in the right order. So I need to like take these self players. I need to not just print the players in position. I need to also sort players by position using my self.players list. So what do I do with that? I think I can tease out. Okay, so I'm going to use list comprehension. So for player, okay, I'm going to basically do this. I'm going to grab that. So for that, in enumerate, so I'm doing this again. I'm going to create a tuple of the position, which is where they're currently located, with the player index. Okay, so this is going to be the position and player I. And now that is going to be a list of tuples where each tuple has 2 elements: the position, the player that player is in, and the player index. And when you do sort on this, it will use the first value in the list, in the tuple, to actually sort by. So I'll kind of show what that looks like here. So let me quickly return this from the function call, and I'm going to see what players are. And instead of this, I'm going to say print turn, which is actually going to return the list itself. So it's not really properly working, but I'm just trying to show you what's going on here. So I've created this list here called position and player I, and that's what I'm returning. And so this is what we're seeing here. So each one is at a different position. So let's actually take the game and say move players. So they're kind of at like different positions basically. So if I print that, now they're all at different positions. This is the position the player is in, and this is the actual index 0, 1, 2, 3, all the way to 9. And so I want to sort by that. So if I take that, so let me store this as like x equals that, and this is what x looks like. Great. If I do x.sort, then x will now be sorted, but it's going to be sorted by whatever's on the left here, basically the first value. So we see that the ones are here, but that's actually not how I want it sorted. I want it to be reversed. So I think sort has, reverse equals false to begin with. So if I reverse the sort, then I get kind of what I want. I want the larger value, which means that they're like further ahead basically. So I want to do the sorting in reverse. So let me just copy this and paste that here. So now player, I don't need the return value. I'm not trying to return stuff here. So position and player index, this list is now sorted, but it still has this shape. So I'm going to use this list in this join here, but I don't want to use this enumerate stuff. So let me remove this for a second, because this is not what I want to do. I want to actually loop through this list, and I can deconstruct this tuple into 2 ways. The first one is the position, so for position, and then player I for the second one. And so everything is working the same like it was basically before. This string is working. Everything should be kind of working, but now everything is sorted in a kind of a nicer way. So let's see how that works. Let's actually play the game, I guess. Play game. And there we go. Look at that. So we see player number 8 is at position 25, and that's actually in sorted order. And so you already see kind of like who's in front first, basically. And you can see, oh, player 6, and eventually player 6 was dominating basically since turn 8, and they won eventually. And we see player 6 wins. Okay, so that works out nicely. So what's cool about this, because the game I was playing in person only had a max of 4 players, which means that, things don't, it's okay, but I kind of like the idea of like having 1,000 players. Since they don't interact with each other, it doesn't really matter how many players there are. So I'm gonna bump this up to like 1,000 players, and that gets like a hot mess. So I don't want to put verbose is true for that. So let me just cut that out. And we see player 134 wins. So good for that person. I could kind of say that I'm done at this point, but I thought it might be interesting because I have my knowledge of how statistics works and data science. I'm going to actually apply some of that here, just to look at some basic stats. So I'm going to look at stats here. I'm going to import Seaborn as SNS. So that's a graphing library. I can see what position players are currently at when the game ends. And I can kind of get a sense of like some of the stats of like what it looks like when the game ends, where players mostly around, and kind of get a sense of how this game is actually working. So I'm going to say his plot, and I'm going to say game.players, and okay, I want to put a little semicolon there to get rid of that little output there. And you can see that it's not like an even amount, right? So it looks like there's some bias towards like this peak at 20 and around like 45 or 50 or so. And there's very little, even none, like around here in the high 60s or low, high 60s, 80s. So that's interesting. We can also bump this up to like a little bit more. So let's have 100,000 players play Snakes and Ladders and see what happens. And if we look at the histogram, look at that. Oh wow, this I think really clearly shows how much bias there is towards this like point here. I think it's point like 16 or so, 18 maybe, and then it's another one at like 40. So it seems to me like if I were to interpret, and I think it's always important to interpret this stuff, never leave interpretation up to the viewer, by the way. Okay, so I think some of my insights would be that when the game ends, there's a disproportionate number of players that are around like tile 20 or 18 or so, and also tile 40. So it seems like the game is kind of like pushing players for the most part to those like reset tiles effectively. And the range between like 65 and like 85 or so, there seems to be a real strong incentive, or maybe like a lot of ladders and snakes around that area that pull people away from those tiles. So my little inference on snakes and ladders. So I'll definitely be sharing the code on some GitHub repo. Feel free to play around with this, make your own game, make it 1,000 tiles, make your own like weird rules of where the ladders and the snakes are, so you can like mess around with kind of the stats to see how the game could maybe look differently in that sense. So that's our first foray into I Can Code That. I hope you enjoyed. If you like this kind of content, please make sure to like, subscribe, do all the good things, and I'll see you next time.